gyroscopes like this beautiful Victorian gyro, all with its own weights and contraptions. I'm going to spin it and immediately ask a volunteer to come and give it a push. So first of all, I'll spin. Now, someone come and just put your finger on this little button here and push towards me very gently. Again, keep pushing. Thank you. It didn't yield to her push, you see. It will go either way. It did something different. Now, we call that something different precession. And I shall have a lot more to say about precession in a few minutes. The Jabberwock was a monster with many heads. It was as if it was, for me, a representative of the way we divide our science into physics, chemistry, biology, and then we take one of those, like physics, and we divide it into heat, light, sound, electricity, and magnetism, then we subdivide that, and so on. Now, some of these heads of the Jabberwock are really laws of physics, I suppose, for me, and some of them look into mirrors and see their own reflections, and they then think there are more of their kind than there really are. The same can probably, from an engineering point of view, be said about the so-called fundamental particles. They try to coexist with each other. Now, the idea of science, in rather perhaps the profession of science, as a monster, is not a new one. Martin Gardner, my favourite author, put it in a neat way in a chapter on the fall of parity. And we talked about parity last time and said that parity was to do with the universe as a whole being handed, having a preference for left or right-handedness without saying which. And Martin Gardner wrote this: "Not one of the three experiments that first toppled parity would have been performed at the time it was performed if Li and Yang had not told the experimentalists what to do. Li had no experience whatever in the laboratory. Yang had worked very briefly in a lab at the University of Chicago, where he was once a kind of assistant to the great Italian physicist Enrico Fermi. He had not been happy in experimental work. His associates had even made up a short rhyme about him, which Bernstein reports. Where there's a bang, there's Yang. Laboratory bangs," went on Martin Gardner, "can range all the way from an exploding test tube, or in our case, a Mr. Coates special, to the explosion of a hydrogen bomb. But the really big bangs," went on Martin Gardner, "are the bangs that occur in the heads of theoretical physicists when they try to put together the pieces handed to them by experimental physicists." One of the things that you may not have been made sufficiently aware of is that there is apparently no simple connection between gravitational mass and inertial mass. When you compare two masses, you can do it either by weighing each on the same spring balance, or by subjecting each to a known force and measuring its acceleration. And the two methods always agree in the answers absolutely. And so, although there's no simple connection, these two heads of the monster must in some way be a curious kind of reflection, the one from the other. Now, in the Jabberwock nonsense rhyme, Lewis Carroll invented some lovely new words, especially for me, slithy and mimsy. They were explained later as combinations of other words which allowed him to express two ideas at once. Lithe and slimy gave rise to slithy. Miserable and flimsy gave rise to mimsy. Now, engineers have been employing this word combination idea for some time, and at first I must say that the words were scorned by the pure scientists because they didn't describe anything that was quantifiable. You couldn't measure it, so it didn't exist. That is a philosophy of its own. But one of the useful ones, which has now become respectable, I will demonstrate to you with the help of 4 blocks of metal on a nicely polished plane surface, and I am going to tilt the plane and see whether all the blocks slide off together as the good book of applied mechanics tells us they should. When the angle of the plane, oh dear, there's one gone already. When the angle of the plane reaches the angle of friction, they should all slide together. but I'm afraid they don't. And if you want to repeat this experiment, you'll have to polish the plane very carefully and clean the blocks. Now, the angle of friction determines the coefficient of friction. Last lecture, I promised you jam tomorrow. Jam you shall have. And tomorrow you shall say we had jam yesterday. Strawberry jam. Now we will do an experiment in friction. I can see myself getting into trouble with some of your mums when you get home and start doing this. Now let us see what the good mechanics book has to say about the laws of friction. That's gone. The friction was increased. Mu had a bigger value. Mu for that one has a very large value. Mu equals, nearly, the lot. Nearly infinity. The angle of friction is now 90, and mu is infinity. We can handle infinity. But what about more than infinity? Now you know what's going to happen. After a while, they're going to peel themselves slowly off the goo and drop. And you see that you made the difficulty for yourselves by defining a coefficient of friction such that if they stuck on the vertical, the coefficient of friction was infinity. A lot of rubbish. The engineer knows what he's doing. He knows what's going on. And it is the job of the engineer to interpret science. You mustn't let it get too pure that it becomes a nonsense. And as far as I'm concerned, I go along with Humpty Dumpty. When I use a word, said Humpty Dumpty, it means just what I choose it to mean, neither more nor less. And so say I with emphasis. For after what I thought to be a clear exposition of a subject in this theatre last November, my use of the conservation of momentum principle was interpreted as a claim to have created momentum out of nothing. How anyone with a PhD could get that wrong, I cannot imagine. But when the journalistic editor got at it, the headline was something like, "Newton was wrong, says Professor." Professor said nothing of the kind. But from then it's a short step to perpetual motion, energy creation from nowhere, and half the crackpots in the kingdom are writing to me, solving the world's energy crisis. It's like the whispering game at a party. After that follows the slings and arrows. You have no idea. And talking of crackpots, Freeman Dyson made these comments in an article in the Scientific American. Most of the crackpot papers which are submitted to the Physical Review are rejected not because it is impossible to understand them, but because it is possible. Those which are impossible to understand are usually published. In the same article, he wrote of a lecture in New York by Pauli to a group of scientists that included no less a person than Niels Bohr. In the discussion that followed the talk, younger scientists were sharply critical of Pauli. Bohr rose to speak. "We are all agreed," he said to Pauli, "that your theory is crazy. The question which divides us is whether it is crazy enough to have a chance of being correct." Now, circularity is a powerful concept. In circular motion, there is magic, as there is in that other thing we call electromagnetism. But like that subject, it is not, the magic is not apparent until it is like, shall we say, rather than its reflection, it's like its neighboring head, truly three-dimensional.